So basically, by way of the statement, he's trying to tell you that there exists a trend in the rate of change of x and the powers of x, and the way we're going to express this trend algebraically, I'll show to you. So for example, you have y, your equation is y is equal to x raised to the power 1. Now your dy by dx, your rate in change in y over your rate in change in x will be equal to, so you'll get this power of x over here, you'll multiply this power of x with x, and you'll subtract this power of x with 1. So this becomes 1x raised to the power 0. And if you remember, anything raised to the power 0 is equal to 0. So the answer, final answer for this is 1. Similarly, for example, you have y is equal to x squared. When you find the rate in change of y, again, I'll do the same thing. I'll multiply this power of x with x. So this is 2. I'll bring this power here and I'll multiply it with x. And then I'll subtract the power by 1. So this will be 2x. And 2 minus 1 is 1. So this is 2x raised to the power 1. So anything raised to the power 1 is equal to 1. So this would be 2x. Right? For example, if I have x cubed, then for x cubed again, I'll multiply this power of x with x. So this would be 3x. And then I'll subtract this power by 1. So then 3 minus 1 is 2. So my final answer would be 3x squared. For example, it's x raised to the power 4. With x raised to the power 4 again, I'll bring the power of x over here, multiply it by x, and I'll subtract the power by 1. So this would be 4x. 4 minus 1 is equal to 3. So this would be 4x3. So basically, whenever I have any power of x, now this is a general rule or general formula following. So whenever I have any power of x, so my equation is y is equal to xn. So if I have to find the rate in change in y with rate in change with respect to x, what I'll do is I'll multiply the power of x with itself. So this would become nx, and I'll subtract that power by 1. And so this is your formula for differentiation. This is your formula for differentiation, and this is something you have to memorize by heart. There's no science behind it. You need to memorize this, and this is exactly what is happening in that sheet of yours over there. Let me go back and show it to you. Let's see how much time we're left with. Okay, cool, we have plenty of time. So for example, if this is x is to the power 1, when you do the rate of change, which is you do dy by dx, so you're finding your differential for this. So you multiply, this was x to the power 1, so you multiply that power with 1, it becomes 1x, and you subtract 1 by 1, and your final answer becomes 0. This is something that I've done exactly over here. When you have x to the power 1, you bring that power of 1 over here, so you multiply x by 1, and you subtract this by 1, so it becomes 1x to the power 0. Anything to the power 0 is 0, so the final answer is 1 for this one. Similarly, when we go back to x to the power 2, you bring the power of 2 over here, you multiply x by 2, and you subtract its power by 1. So this becomes 2 minus 1 in the numerator, like with the power, and this overall becomes a multiple of 2x. And the same thing we've done over here. We brought this power of 2, and then we subtracted the power of 2 with 1. It became x raised to the power 1. Anything with raised to the power 1 is actually 1, so you don't need to write it here. So the overall expression is 2x. Now if you look over here, he's done the same thing with x raised to the power 3. When you bring 3 over here, it becomes a multiple of 3, and you subtract the power of 1. You subtract the 3 with 1, and you get 2. Similarly with 4. When you take the power over there, you multiply it with x, it becomes 4x, and you subtract this power by 1, it becomes 3. X is to the power 6, you take x5 over here, you multiply x with 5, and then you subtract the power by 1. X is to the power 6, you take the power of x over here, and you multiply it with x, it becomes 6x, and you subtract this power by 1. And so this is basically what differentiation is. This is what the rule of differentiation is. this is a formula of differentiation, that when you have y raised to power n, you multiply that power with n, and you subtract the power by 1 at the same time. So this is your final result for differentiation. And all this exercise that he had done before was just to explain to you how he arrived at differentiation. So when he was trying to say that y is equal to x squared plus 3, you will see that the rate of change for this thing which you calculated yourself was 2x. So for this y is equal to x squared, stupid tool. So for y is equal to x squared plus 3, you found out that the rate of change differentiation was equal to 2x. So it's the same thing. He took the value of 2 over here, multiplied it by 2, and subtracted 1 from the numerator. So for x squared, forget 3. For x squared, your differential was 2x. Similarly, for 3x, your differential was 3, just the number, which is that you took the power of 1 and you multiplied it with 3 and you got 3. And so the overall expression becomes 3 into x raised to power 0, because you subtract this 1 by 0 and you get 3. So this is the rule of differentiation. ये आपने इस equation को रट्टा लगाना है. This is a very important equation. This is how you will carry out your differentiation. Alright? Now let's go to another example. Why does something go wrong? Wait. This girl Ikra speaks outside my door all morning. She really has replaced you. And I'm so freaking pissed off. So now, let's try to do some more examples. Now, for example, I have an equation with me. Y is equal to, what hideous color is this? Y is equal to 5x raised to the power 2. So when I will find the differential dy by dx, I will take this power and multiply it with x. So this time 5 is being multiplied by x. So 2 will also get multiplied by x. So this will become 10. And then I will subtract this power with 1 and I will get 10x. Let's try another example. For example, I have y is equal to minus 2x raised to the power 3. So my differential dy by dx would be, again, I will take this power of x and I will multiply it with x. And this time minus 2 is being multiplied by x. So this 3 would also get multiplied by x. So it will become minus 6. And then x would, the power of x will be subtracted by 1. Because every time you take this power here, the rule is that you have to subtract this power with 1. So this will become minus 6x raised to the power 2. So what we're trying to, and let's try another one. Let's see how much time I have, or if I need to start another video, because it keeps recording and I don't know, and then my time runs out. Okay. Let's try another example. For example, I have y raised to power anything, y raised to power a, and I have x raised to power n. So every time I carry out the differentiation for this dy by dx, what essentially is happening is n is getting multiplied with whatever x is being multiplied with, and at the same time, every time that I take n over there, I subtract it with 1. So this is again your general formula or your rule for differentiation. It's the same thing that we did before, only in this case what is happening is that x is already being multiplied with something else. So whatever the power of x is, it gets multiplied with that also, and you subtract the remaining power with 1. And we'll continue this in the second video, and this is basically what differentiation is.